Hello, in this video I will cover a hypothetical developmental network. First things first, a developmental network is a way to depict the interactions of various regulatory genes within an organism that result in a phenotype. This depiction shows regulation as a sequential series of events being read left to right, with the genes either inhibiting, as shown by T-bars, or promoting, as shown by arrows, the next gene in the developmental pathway, with the resulting phenotype being the last component of the network. The following hypothetical developmental network involves the expression of spikes in the ectodermal spike cells of a spiny beetle, with S activating P, which can activate I, which can inhibit K, which can inhibit E, which can activate the formation of spikes. Mutations within the genes of these developmental networks can impact the ability of the cell to produce spikes. If a spike cell has a mutation in the P gene deactivating it, it cannot be activated, which leads to I not inhibiting K. K can then inhibit E, which prevents E from activating the formation of spikes, resulting in a smooth cell. I will disregard the genes to the left of the mutation, as the mutated gene will not function regardless of what came before it. If the I gene is mutated, it cannot inhibit K, allowing K to inhibit E, which leads to the formation of spikes not being activated, resulting in a smooth cell. In the case when there are two mutations, anything that is left of the furthest right mutation can be disregarded. When I and E are mutations, the mutation of E prevents the activation of spikes, resulting in a smooth cell. When S and K are the mutations, mutation of K prevents the inhibition of E, which allows E to activate the formation of spikes, leading to a spiky cell. While mutations can impact the ability of a spiky ectodermal cell to produce spikes, what accounts for spiny beetles having some ectodermal cells produce spikes and some not? A hypothesis for this is that a gene from the developmental network is being regulated by DNA methylation. DNA methylation is the addition of a methyl group to DNA by a DNA methyltransferase. Addition of a methyl group to a gene tends to turn the gene off. Therefore, different methylation patterns in the ectoderm cells can cause some to produce spikes and some not to. If the I gene was methylated, this would prevent it from inhibiting K, leading to K inhibiting E, which would lead to the formation of spikes not being activated, and a resulting smooth cell. If I was unmethylated, it would be turned on, in this case, and would inhibit K, allowing E to activate the formation of spikes, leading to a spiky cell. Differences in the methylation of the I gene can therefore allow some ectodermal cells to be smooth and some to produce spikes.